Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about another data cleaning task. In our previous lecture, we have learned missing data, or we have also learned how to handle missing values. In our today's lecture, we are going to learn about how we can remove the noise from the data. So for that, let's understand what is a noise. So noise is a random error or a variance in a measured variable. Suppose you are measuring the temperature of your body, yes, but if thermometer is faulty, then your measured value will be wrong. Yes, so that is the variance or the errors in your measured variable. So that data is wrong. That is why it becomes the noise. Yes, so that is so all the types of data is also called the noise. Noise in the data may be in a random. Noise in the data may be introduced due to some reasons. Reasons like fault in data collection instruments, error introduced at a data entry by a human or a computer, data transmission error, technology limitations, inconsistency in naming convention. Yes, all are the reason. By that reason, the noise in the data will introduce. Other data problems or other types of noise in the data like unknown encoding. Suppose you have one column of gender. So gender contains only two values, male or female. Yes, but people are writing some other values like ABC, XYZ. So that values are become the noise. Second reason is out of range values. Suppose you are asking for the temperature and people writes a 1004 degree. So that is not relevant for our day-to-day life. Yes. Suppose you are asking for the age and someone writes 2005 and 2005 age value of a human. So that is also not a valid value. Inconsistency in entries, like you are asking for the date of birth. So someone writes 10 February 2003 and in the age field he is writing 30. So the birth date and age will not match. Yes, so that is called the inconsistent entries. Inconsistent format. Suppose you are asking for the birth date. So someone writes 11 February 1984. Someone writes 2/11/2007. Yes, the format is different. So that all types of data are called the noise. So we have to remove that noise for the further processing. So for remove the noise, or we can say that to polish your data, there are multiple techniques that are available to handle the noisy data. So there are mainly three types of technique. And using the techniques we can handle the noisy data. First is a binning method, second is a clustering, and third is a regression. Yeah, so binning method smooth a sorted data by consulting a neighborhood, that is the value around it. The sorted values are distributed into a numbers of buckets, bins, and because binning method consults the neighborhood or neighborhood values, they perform a local smoothing. Yes, so by smoothing we are deleting or we are cutting the noisy data. Binning can be done by the three methods, which is smooth by bin mins, smooth by bin median, and smooth by bin boundaries. Second method is clustering. It is used to detect and remove outliers. And third is a regression. So it is used by smooth fitting the data into the regression function. So in our today's lecture we are going to learn only one method, which is a binning method. The rest tools we'll learn in our later session. Let's understand binning with some example. So as I said that binning has three methods: smoothing by bin means, smoothing by bin medians, and smoothing by bin boundaries. So first so the binning method can be used for smoothing the data. Mostly data is full of noise. So data smoothing is a data pre-processing technique using different kinds of algorithm to remove the noise from the data set. So this allows the important patterns to stand out. Yes, so by using this method we can remove the noise from the data. So to understand that, let's understand how we can create a bins of the data. So first thing is how to create. So it has mainly two methods. First is equal depth partitioning, or also we can say that equal frequency or equal height. Yes. So the first method is equal depth partitioning. It is also called equal frequency or the equal height partitioning. So in this method, the entire range is divided into n intervals. Each contains approximately the same number of samples. So this is a good data scaling. So to understand, to understand this method, let's consider one example, and for that let's take one data points. So the data points are suppose 4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29 and 34. So this is the data of your database, suppose. So the first step for any binning method is sorting the data, okay, into the ascending order. So first let's sort this data. So as by showing the data, this data is already sorted. Yes. So suppose if you have some data and the data is not sorted, so the first thing is you have to sort that data. After sorting the data points are this. Suppose these are the sorted data points. Yes. So now if you wanna bin that data, or you want to divide the data into the bins. So for that you have to create a bins. Suppose you want to create 3 bins. So let's create a bin 1, bin 2 and bin 3. Yes. So there are 3 bins, and so you have to divide the data in such a way that each bin has the equal data. So if I take these 4 data values, then we can say that it creates a equal data points in each bins. Bins means you can consider each bin as one bucket. Suppose you have one bucket and you have to fill that bucket equally. So that concept is same as the binning. So now let's fill that bin like with 4, 8, 9 and 15. Second bin is 21, 21, 24 and 25. Third bin is 26, 28, 29 and 34. So now it is now the data point is ready for further process. So this is a simple method. From that we can create a so this is one simple method, and by using this method we can create a bins of the data, or we can divide the data. So this is the first way. In exam there are some sums, and in that sum mostly the equal depth partitioning is asked. So this is very important method. The second partitioning method is equal width. Okay. So it divides the data into n intervals of equal size. Yes. So it is something like, suppose this is the data. So we have to divide the data into the equal width, not in the equal depth. Yes. So in the first method, in the equal depth method, we are dividing the data point into the equal defs, while in the equal width method we have to divide the data points into the equal width. So this is the basic concept. So for that, if we want to find the bin width, so the equation for bin width is equals to max value minus mean value divided by number of data points. So this is the equation for bin width. Suppose you have a data range of 0 to 100 and you want to divide the data into the equal bins. Suppose this is a 0 value and this is a 100 value, and you have the task is divide the data into the equal width. So how you can do this? So for that we will use the equation bin width is equals to, here we know that maximum value is 100 minus minimum value is 0 divided by n. N means in how many intervals you want to divide the data. So suppose we'll take it n as a file, so the answer is become 20. So now we can divide the data into the equal width, but the main important thing needs to be remembered is the first and the last bins is extended to allow a value outside the range. So that is why the value is become the infinity. Now if we want to divide the data into the bins, then first bin is something like that, second bin is something like that, etc, etc. So the first bin is starting from the infinity, okay, always, and we know that the width of the each bins means suppose this is a one bin, then it contains a 20 data points. So this is called the bin width. Okay, so this is, so if we are creating the bin width, then first is a infinity, second is a 20. Now from 20 to 40, suppose it is not a square bracket, second is 40 to 60, 60 to 80, 80 to 100. So we are 80 to 100. So we are not writing it to 100, we will write as a infinity. Yes, so this is a common rule that if you are using the equal width partitioning, then in the first bin the first value is infinity, and in the last bin the last value is infinity. So this is how we can divide our data points into the equal bins, equal width bins. So there are mainly two methods. In the first method we are dividing data into the equal depth. In the second method, which is equal width partitioning, in this method we are dividing data point into the equal width. So this is how we can do this. Now let's understand the first method of smoothing. We know that the first method is smoothing by bin means. Smoothing by means. Means we have to find the mean and replace the value to the bin. So let's start. Suppose we have data points like 2, 10 to 19, 10 to 19, 18, 20, 18, 25, 28 and 22. Yes, so these are the data points. Now first step is sort the data. Okay, so we are sorting the data into, first is a 2, second is a 10, third is a 18, fourth is 18, fifth is a 19, 20, 22, 25, 28. Yes, so now this is the sorted data. after sorting the data, suppose in the exam you have a question like divide the data into the bins of size 3. So now we'll consider n equals to 3. Yes, this value is already given in the exam. With the method equal depth partitioning. Yes, so here also two things is provided in the question, like the value of n and which method you have to use for partitioning the bins or partitioning the data. So here the method is equal depth. Now you have to do it by equal smoothing by bins. So we all know how we can partitioning the data with the equal depth. Now we have value of n. So the bins created are bin 1, bin 2 and bin 3. Yes, because the value of n equals to 3. So we have to create a 3 bins. Each bin contains the equal value. Yes. So we know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So for the equal partitioning of the data or for equal division, each contains 3 data points. Yes. So the first 3 data points reside in the bin 1. The second 3 are in a bin 2, and last 3 are in a bin 3. Okay, so the task is done. So this is a step 2. In step 3, you have to smooth the data by the bin mean. Now what is the meaning of mean? How we can find the mean? Yes, so in our previous lecture I will show you what is the equation for the mean. So mean equals to number of data points, sum of data points divided by numbers of data points. So this is the equation of mean. So we have now we have to find the mean of each and every bin. So the third step is calculate the mean of each bin. Now bin 1 is equals to 2, 10, 18. So mean equals to 2 plus 10 plus 18 divided by 3. So is equals to 30 divided by 3 is equals to 10. Yes. So the median value of bin 1 equals to 10. Now bin 2 is equals to 18, 19, 20. Yes. So 18 plus 19 plus 20 mean 2. Yeah, 1. It is a mean 1 divided by 3. So what is the sum? So 57 divided by 3 is equals to 19, and M3 is equals to bin 3 is equals to 22, 25, 28. So it becomes M3 becomes 22 plus 25 plus 28 divided by 3 is equals to 75 divided by 3, so is equals to 25. So the value of M3 is equals to 25. So now we have the value of bin mean 1, mean 2 and mean 3. Yes, we have each value of, we have a mean value of each bin. So the last step, step 4, is equals to replace each value in the bin with respective min. Its mean value. Yes, so at last we'll create a 3 bin again, bin 1, bin 2, bin 3. Now we'll replace each value of bin with its mean value. We have m1 is 10, so we'll write 10, 10, 10. We know that the value of m2 is 19, so we'll replace bin 2's value with 19. And we know the value of bin 3 is 25, so we'll replace it with the 25, 25 and 25. So now the data is generated. This data is a smooth data, so it will remove the noise from the data. So this is how we can calculate the smoothing data by bin means method. So I will repeat all these steps. The first step is sort the data. First step is sort the data in the ascending order. Second step is divide the data into the bins by using the equal def or equal width method. Third is calculate the mean. So we'll calculate the mean of each bin. And the last step is replace the each bin's value with its mean value. So this is how we can calculate the bin by means smoothing. This is how we can calculate smoothing by bin means. The second method is smoothing by bin median. So to calculate the bin median, first we have a data points 10 to 19, 18, 20, 18, 25, 28 and 22. The first step is same, sort the data points. So these are the sorted data points 2, 10, 18, 18, 19, 20, 22, 25, 28. Yes. After sorting the data, the second step is divide the data points into the bins by equal depth method. This is equal depth or equal width that is mentioned in the question, and also the n is also mentioned in the question. So here n equals to 3 and we have to divide the data into the equal depth. So we are creating bins, we are creating 3 bins because n equals to 3, and we are dividing the data. We are dividing 3 and we are dividing data equally so that each bin has the same value. So each contains the 3 value 2, 10, 18, 18 and 20 and 22, 25 and 28. So step 2 is complete. We are now we have a bins. Now we have a bin ready. The next step is calculate the median of each bin, because the method is smoothing by bin median, so we have to find the median of each bin and then replace the value. Yes, so the median has an equation like n by 2 number of data points divided by 2 if the data points are even, and if data points are odd then divide by 2 and round up the value. So this is how we can find the median. So let's do it by taking the bin 1. So bin 1 has a value 2, 10 and 18. Yes, so we have 3 data points. So 3. So to calculate the median, we have 3 data points. So 3 divided by 2 it is a 1.5, and if we round the data value, then it becomes the second value. So second value means the second value of bin. So second value of bin is a 10. So now the value is become, median value is become 10. Same as in bin 2, we have three value 18, 19 and 20. And also we can count the median values with n by 2. So we have 3 data points. So 3 divided by 2. So it is also a second value 1.5. So by round by rounding the value, it becomes the second value. So in bin 2, the second value is 19. So the median value is become the 19. Same as in bin 3, we have 3 data points. So 3 divided by 2, it is equals to 1.5, and by rounding, it is a second value. So second value of bin 3 is equals to 25. Now we have a median value of each bin. Bin 1 has a value 10, bin 2 has a value 19, and bin 3 has a value 25. So the last step is replace the bin value with median value. Yes. So for that, we are creating a bin 1, bin 2 and bin 3. So we know that the median value of bin 1 is a 10. So we'll replace all three value with the median value 10, 10 and 10. We know that the median value of bin 2 is a 19. So we'll replace all the value with 19. And we know that median value of bin 3 is 25. So we'll replace all the value of bin 3 with the 25. So this is the final result. So this is how we can do the smoothing by bin median. Thank you so much for listening. Have a great day.